Hello everyone, welcome back. I hope you had a good weekend. We are going to continue here with chapter 10. Today we're going to look at ellipses centered at 0, 0. On Thursday we'll move those ellipses around and start looking at ellipses with other centers. I want to start off really quickly here with the definition of an ellipse. So for a parabola, we talked about how the conic definition of that is that you have this focus and you have this directrix. And the parabola is made up of every point that is equidistant from those two things. So if you pick a point over here, the distance from that point to the focus and the distance from that point to the directrix, those will always be the same, right? For any point on that parabola. So here's how an ellipse is different. An ellipse, the definition is, for an ellipse, the set of all points in a plane whose sum of the distances from two fixed points, called the foci, is constant. So foci just is plural for focus. So there's two focus points here in an ellipse. And it says the sum of the two distances is always constant. So basically, if you pick any point on this ellipse, and you measure the distance from that point to this focus, and you measure the point from the distance from that point to that focus, let's imagine that it was 6. So this first distance and that second distance, d1 plus d2, would equal 6. Let's say you picked another point, anywhere. Say it's down here, right? You measure the two distances to the two foci. So one distance there and another distance there, okay? If you added those two distances up, say d3 and d4, d3 plus d4 would also be 6. So you can keep that going for any point along this ellipse. There's infinite number of points along that ellipse, and all of those two distances, for distance from one focus and the other added up, would be 6. So that is the conic definition of an ellipse. Now, here's some good things to jot down. And by the way, there are blank notes on Schoology if you'd like to fill those in as we go. For a horizontal ellipse, a horizontal is just kind of wider side to side than it is up and down, has this equation right here. We have x squared over a squared plus y squared over b squared equals 1. So one thing that's weird about these conics is that each shape has its own set of variables we used, right? For parabolas, we only use the a value, and the a value took us from the vertex to the focus and from the vertex to the directrix. The ellipses use these a and b values. Okay, so the first thing to remember is that the a value has to be greater than the b value. This first value out front is the a, and that's got to be greater than b. Going forward, we're going to know an ellipse. See how both of the variables are squared now? Remember last week I told you for a parabola, only one of those are squared. So when they're both squared, it's an ellipse. Let's talk about the a value now. So the a value here is important because the a value takes you from the center. Okay. Oh, I don't want to do that. Let's try again. From the center to the vertex. That is the a value. Now that goes both ways, left and right. I'm not going to draw it right because it gets a little too crowded. The b value, that's right here in the equation, and remember, in the equation is b squared. We want the b and the a value. The b value takes you from the center up and down to what is called the covertex, or the covertices. Okay? And then the c value, which we find down here, there's a little equation there you got to know, c squared equals a squared minus b squared. The c value is what takes you from the center to the focus. Now to each focus, right? There's one over on each side, but that is the c value. So first thing you got to really know is what the a value, the b value, and the c value do, okay? And what points they take you to. A to the vertex, b to the covertex, c to the focus, right? And there's 2 of each of those. Other vocab you got to know is the major axis is the blue axis. That's basically the bigger of the two axes. And the minor axis is the red axis here. That's the smaller of the two. Those are basically 2 lines of symmetry. Okay. That's horizontal. Now look at a vertical. Vertical because it goes up and down more than it goes left and right. Not much changes here. The only difference, same equation, but look what happens. The a squared and the b squared are flipped. A is still bigger than b. So basically, in the first one here, you're going to have a bigger number under the x value. In the second one here, vertical, you're going to have a bigger number under the y. That's how you know whether it's a horizontal or a vertical ellipse. This little equation is the exact same thing. C squared equals a squared minus b squared. The a value does the same thing. The A value takes you from the center to the vertex. This time it goes up and down. The B value takes you from the center to the covertex. This time it goes left and right. The C value takes you from the center to the focus. This time it goes up and down. Okay. The major axis now is up and down because it's longer, and the minor axis is left and right because it's smaller. And that's it. Okay. One other thing to keep in mind here, the foci. If you look back at the last two pictures, they always lie on the major axis. So they're always going to go horizontal ellipses are going to go left and right. Vertical ellipses are going to go up and down to get to the foci. Okay, let's try a few of these. So here we're going to start off. I'm going to give you the equation. You're just going to sketch everything. You're going to find the center, the vertices, the covertices, and the foci. Everything should be written as points. Today, the center is going to be at 0, 0. That's nice. On Thursday, we're going to change that. Just like we did with parabolas, we're just going to add an h and a k in there. So here's the center. If I look at my equation over here, right, I know the a value. Now be careful. The a value is that's a squared because it's the bigger number. So my a value is the square root of that. My b value is the square root of 8, which is 2 root 2, right? And then to find my c value, I got to use that little equation, a squared minus b squared, okay? So if I pop everything in there, a squared is 16, b squared is 8. I get a c squared of 8. If I square root both sides, I get a c value of plus or minus 2 root 2. Now, it doesn't have to be a plus or minus. All of these values, a, b, and c, they're going to go both ways, up and down, left and right. So really, you're going to do a positive and a negative thing with both of them, okay? So next thing I want you to know is whether this is horizontal or vertical. Because the bigger number is under the y value, this is going to be a vertical ellipse, up and down more than it is left and right. Now, there's a little trick for this. If you ever get confused with which one's the a and which one's the b, you can always remember this too, and this is nice because this holds true with hyperbolas too, is whatever number is under the y value, that's going to move you up and down. Whatever number is under the x value, that's going to move you left and right. And that is always true. So you can see here, because the 16 is on the y, the up and down movement is going to be more than the left and right. That's why it's a vertical ellipse. And we'll keep talking about that later on. Okay, so up and down 4 because it's vertical. I'm going up to there. I'm going down to there, and those are my vertices. I'm going to label those as points. So it's 0, 4, and 0, negative 4 are my 2 points. For the covertices, I'm going left and right, 2 root 2. Square root of 8 is almost 3, right, because the square root of 9 is 3. So 2 root 2 is maybe right about there and right about there. Any radicals or decimals, you'll just have to approximate. Now, you might have noticed with these first ones, the vertices, I could have written that in one set of parentheses. So let's write this like that. This would be plus or minus 2, plus or minus 2 root 2, comma 0. So either two separate points like we did for the vertices, or you can write it as a plus or minus, like we did here, plus or minus 2 root 2, comma 0, because it went left and right. Remember, the weird thing about these ellipses, or all conics, is we don't really use the equation. We don't use an XY table. We use the patterns we know from the equation to sketch the graph. Okay, once you have the covertices and the vertices, you actually can sketch the graph. Okay, again, you want to make it as symmetric as you can. This is going to be a little bit hard to do on the iPad, but I'll do the best I can. Yeah, that's decent. All right, so now let's do the foci. Foci, they're going to go along the major axis. That means they're going to go up and down. The c value is 2 root 2, so I'm going up almost 3. I'm going down almost 3, and there are my foci. Label those as points. Again, I can do them in one pair of parentheses. Again, there's 2 points there, but I'm just labeling them in one parenthesis. And that's it. That's my ellipse. Not too crazy. You just have to be really comfortable with these two equations and what the a value does, what the b value does, what the c value does, and how to find everything. Okay? So pause the video here. Well, actually, let me show you one step here. We're going to let you guys finish this on your own. You have to know those equations really well because right away I can tell I'm not in the right form. Now, linking it back to last week, I know right away this is not a parabola because both of the variables are squared. It's got to be an ellipse. Next week we'll talk about hyperbolas. Hyperbolas have a minus sign there with a plus, and they still have two squared variables. So that's how you can tell all of them apart. So to get this to look like in the standard form, I need a 1, or to be in standard form, I need a 1 over there. Okay? So the only way I can make that happen is divide everything by 36. Okay. Now when I do that, I get x squared. 4 over 36 reduces to 1/9. I get a y squared. 9 over 36 reduces to 1/4. And there I get a 1, and I've got to make the equation look like that in order to use what I know about the A, B's, and C's to graph it. Okay, pause the video, try to identify A, B, and C, and sketch a graph. Okay, so the center, 0, 0. Hopefully you notice this is a horizontal ellipse because the bigger number is under the x value. Again, if it confuses you, just remember, the number under the x is going to move you left and right. The number under the y is going to move you up and down. A value here is 3, square root of 9. The b value here is 2, square root of 4. The c value is the a value, a squared minus the b squared. So c squared is 5. So c is plus or minus the square root of 5. Okay. From the center, because it's a horizontal, I'm going left and right 3 units to get to my vertices. So that's plus or minus 3, 0. I'm going up and down to get to my covertices, up and down 2. Those 2 points are 0, plus or minus 2. Vertices and covertices are all I need to sketch a graph. So here's my ellipse. Again, trying to make it as symmetric as I can. All right. Foci then, because this is a horizontal, I'm going left and right. So it's plus or minus the square root of 5, 0. And there are my points, and there's my graph. All right. Now, going forward, later this week, or actually next week, we're start looking at some applications. One of the most famous applications of ellipses are planets and their rotations. You know, our sun is in the center of our solar system, but we don't rotate around it in a circle. We actually make an ellipse motion when we rotate around the sun. Another cool application of ellipses are these things called a whispering gallery, where one person stands at one focus, the other person stands at another focus, and you can actually whisper from one person to another across the room. Reason being is the sound waves reflect off this elliptical dome-shaped roof and go right to the other focus. We'll talk more about that when we do applications. I just kind of wanted to show you where these are going. Okay, let's do one where we're working backwards. Now, there's going to be a few in the homework where I give you information like this, and you got to work backwards. And there's going to be a few where, sorry, I got a timer going off here. There's going to be a few where you get the graph and you got to work backwards. It's the same skill though. Okay, so let's find the equation here. Center is at 0, 0, the origin. And again, that's going to be for all the graphs today will be at 0, 0. There we go. So center here is at 0, 0. I get one focus at 0, -3. So 0, -3 down there. I'm going to label that F for focus. Okay. And I got a co-vertex at 5, 0. So I'm going to label, well, I don't need to label that. I'll label it as a co-vertex. All right. So right away, what I should be able to do is come up with other co-vertex over here, CV, and another focus up here. Okay. So now, what do I know? I know that the B value is 5. I know the C value is 3, right? What's unique here, though, is I don't know the A. Remember for the equation here, it's always going to be x squared, plus some sign. It's always going to be y squared. It's always going to equal 1. What I need under here, I need A's and B's. Now, should be able to tell from what I have already that this is going to be a vertical ellipse. It's going to look something like this. The foci have to be on the major axis. So I know that the bigger number is going to be under the y's, because it has to go up and down more than it goes left and right. So this b value right there, I know that's going to be under the x's. And not just the b value, the b squared is going to go under the x's. Okay? So what I've got to find here is now the a squared. So what I'm going to use is the same equation I've used before, c squared equals a squared minus b squared, but I'm going to solve for a different variable. I'm going to solve for a. So I plug the a and the c in, I get that. If I add the 25 over, I get a squared equals 34, and really I can stop there. I could find a and, actually it wants me to graph it, so I will finish that in a second. But right now, there's my equation. A squared goes in the denominator under y. That is my equation of the ellipse. And now if I want to finish the graph, I know that a is plus or minus the square root of 34. That's just shy of 6. So I'm going to up a little bit less than 6 and down a little bit less than 6. And there is I can sketch a graph now. Again, try to make it as symmetric as you can. A little harder to do on the iPad, but that's pretty decent. Okay, almost a circle, but not quite. Okay, guys, that's it. Homework tonight for this assignment is 10.3 day 1 on MyLab Math. As always, if you have any issues or questions, feel free to stop by my office hour from noon to 1 p.m. And I hope everything's going well. You can also email me with any issues, but office hour is nice because we can talk live and answer your questions. Okay, take care.